Hello, everyone. Today, I'm going to do a short sharing with all of you, knowing that weighted assessment weeks are coming up. Well, thinking about the word weighted assessment, probably you would be like the cat over here. Yeah, starting to worry, starting to feel anxious. And that's very true. So here I'm offering some tips on how to find the gradient of a straight line. I'm going to provide you two methods, and hopefully you will find that it's a useful session. Yeah, so let me just go into the share screen mode. All right, let's go straight into finding the gradient of a straight line. Finding the gradient of a straight line is taught in secondary 1, express, maths, as well as in secondary 2, normal academic maths, and in secondary 2, later half of the year in normal technical maths as well. So how do we go about finding the gradient of a straight line? This is one thing that many students kind of stumble over because it's something that is so abstract. It's not clear. Something like we can see in real life. You know, we don't see straight lines appearing just like that, you know, unless we see an application of something. So what is gradient exactly? Gradient is not really a word that we use in most of our sentences, right, day to day. Well, in a mathematical context, the gradient of a straight line is a value to describe the extent of slope of that straight line. Okay, so if you have a straight line that is steep, the value of the gradient is greater. If the straight line is not so steep, the value of the gradient is lesser. So if I were to draw you two lines, okay, we have line 1, I'll label it as L1, and we have line 2, L2. Comparing L1 and L2, which one is steeper? Which one is less steep? So looking at them, you probably say that L2 is steeper compared to L1, right? And how would you describe L1? L1 would be described as less steep compared to L2, or you can say it is gentler. In terms of the gradient, L2 would have a value of the gradient that is bigger than L1. So for example, the value of a gradient could be, say, 5. And an example of the gradient of L1 being more gentle could be something like 2. Okay. Now, on the other hand, let's move on to the third point. A straight line that slopes upwards has a positive gradient. Now, what do I mean by sloping upwards? So let's say if I were to consider L1, okay, and we have start point of the slope and end point of the slope. Now, as it goes, as the line is being drawn, you realize that from left to right is going upwards. So this is a straight line that slopes upwards. For L2, you notice that again, on the left-hand side, the start point is at the bottom, and on the right, towards the right-hand side, the end point is at the top. So this slope is also going upwards. These two have a positive gradient. On the other hand, if you have a straight line that slopes downwards, so if I were to draw an example of two lines, perhaps one line again, okay, this time around I will draw L3. Okay, now, can you tell me where is the start and the end point of that line? So start point always starts on the left, right? So this is the start point. all the way to the end point, which is here. Okay, from left to right is going down. It slopes downwards. So this straight line has a negative gradient. And if I were to give an example of a negative gradient, it might be something like -3. Okay, what tells you whether something is positive or negative? Well, the sign that goes before the value would tell you whether it's positive or negative. Now, next portion, I'm going to move on to something called the equation of a straight line. The equation of any straight line is y equals to mx plus c. Whew. 4 letters. What do they stand for? This might be one of the questions that you ask yourself. Huh? What's that? Okay, now let me break this down. X and Y here basically refers to a pair of coordinates found on this straight line. Okay. So if you recall, coordinates is written in a form within a bracket, with the first blank being the y coordinate and the first blank being the x coordinate and the second blank being the y coordinate. So for example, 1, 2. Okay. Now this M and what is C? So let's take a look at M. M here refers to the gradient of the line. And for C, C refers to the y-intercept of that line. Okay, so I have talked about what gradient is. I have also spoken briefly about x and y, which is a pair of coordinates found on the particular straight line. So what exactly is the y-intercept? Now the y-intercept can be found at a point where the line crosses the y-axis. Okay, y-intercept, right? So let's say if you have a line and this line crosses the y-intercept. Y-intercept is this part. Okay, so the value over here is the y-intercept. The value over here is C. So let's say if you were to look along the y-axis, and this value over here, okay, let's say this is 2. Okay, you see that the line crosses the y-axis at y equals to 2. So the y-intercept, which is represented by the letter C, equals to 2. All right. Let me give you another example of how to find the y-intercept of another straight line. So let's say if you have another straight line like this, okay, this would be L5. And I want to find the y-intercept. Okay, this is my 0. Let's say this is my -1, and I have my -2, -3. We can see that L5 actually crosses the the y-axis at this point. Yeah, so if it crosses at this point, we can say that the y-intercept is -2, or we could say that C is equals to -2. So now, after this short explanation, you have known what x and y is, you would know what M is and what C is. How do we find the gradient of a straight line then? Now there are 2 methods. The first method is to remember that the gradient of a straight line is equals to the rise out of the run. Okay. Now, what is rise? Rise, we try to remember and associate rise with the rising of the sun. Or if you're asked to rise from your seat, you rise upwards, right? Yeah, you get up from your seat, isn't it? So you rise, okay? And it's a vertical movement. Out of the run. Now, associate it with a run that you take during PE lesson. When you run, you run across, right? Horizontally. You do not run upwards. So this is considered the horizontal movement. Okay, with this in mind, let's consider how we may find the gradient based on rise over run. So let's take a look at the straight line on the right-hand side of the page. Okay, now we have this straight line, and let's consider the rise out of the run. Before we can consider rise out of run, we need to consider the span of the slope that will give us the rise and the run. So let's say if I were to consider only this part, okay, of the slope. The slope actually goes right all the way down, okay, all the way up. I do not need to consider the entire slope, but perhaps just I start at a very nice point where, okay, one on the x-axis and one on the y-axis coincides. This is called a nice point, okay, because it's not like a 1.2, 1.6 or something like that. It's a whole number, really nice. And the end point, I'm going to consider this, okay? So in terms of coordinates, just for reference sake, this would be 4, 4. Okay, I'm going to put this down. Okay, now how do we calculate the rise out of the run? The rise is the vertical portion. Okay, where this slope moves. So the slope starts from here, right? And it ends here. So how much does it rise up by? So let's consider this as the rise. How many units does it rise up by? So let's see. It goes up by 1, 2, 3 units. Yeah. So the rise is 3. And the run, we use another color. The run would be the horizontal distance from the start to the end of the slope. Now, how many units does it run by? So we have 1, 2, 3. 3 units. Now, one more thing we have to consider, is this gradient upward sloping or downward sloping? So you can see from the yellow highlighted portion, it is moving upwards, right? From left to right, it's upwards. So if it is upward sloping, then gradient is positive. Yeah, I'm going to put down positive gradients. Okay, so if it's positive gradient, I need not put a plus sign over here. Answer therefore is 1. Okay, so this is method 1, using rise over run. Now the other method would be using formula. And that would be y2 minus y1 over x2 minus x1. Okay, some of you are taught this method by your teachers. And what exactly is x2, x1, x2, y1, y2? Now, x and y here refers to the coordinates. Okay, and the first pair of coordinates that we identify with, let's say we take 4, 4. This can be x1 and y1. Okay, x1 refers to the first coordinate. Let me use yellow. This one refers to the first coordinate of the first x coordinate. And y1 refers to the second, the first y coordinate. I'm not awake yet. All right. And subsequently, we can see that for the other pair of coordinates, I will write it as x2, y2. Okay, so we can say that for the second set of coordinates, the x coordinate would be x2 and the y would be y2. Okay. So now that we know what stands for which number, we are going to substitute these values into the formula to get the gradient. Okay, so y2 minus y1. Okay, where is my y2? My y2 is here. So my y2 value is 1. My y1 value is 4. So 1 minus 4 out of x2. x2 value is 1 and y2 value is 1. It's 4. Okay, so I will end up with minus 3 in the numerator and minus 3 in the denominator, and that works out to 1 as well. So this is making use of formula. Decide which is your preference and go with one method. I think that would work well. Okay, now let's take a look at another example in terms of finding the gradient of a straight line. So let's consider a part of the line that we want to get our rise and our run. So let's say we want to consider this, okay? Now, why are these good points to start and end off with? Because here is the intersection of the x and y values that are whole numbers, that are integer values. So this would be 0, 2. And at the end point, it's 3, 0. Okay, really nice and whole values. So method 1, gradient being the rise over the run. Okay, now what's my rise? What's my run? So if I were to consider rise, this is my rise, okay? So the vertical change. Rise, how many units? So my rise, you realize that it's going up by 2 units. And my run, how many units? 3 units. So 2 out of 3. And before that, I will have to consider whether this is a slope that goes upwards or downwards. It is from left to right, downward sloping. So therefore, there is a negative gradient involved. Okay. Now take note that for the rise and run, right? I forgot to mention this earlier. These two lines, the blue and the green ones, when you draw, it has to meet at a right angle. Yeah, to form a right angle triangle. Okay, now method 2, gradient equals to y2 minus y1 over x2 minus x1. Let's take this as x1, y1, x2, y2. Okay, so y2 minus y1 will be 0 minus 2 over x2 minus x1. x2 is 3, 3 minus x1, which is 0. So when we work out our answer, we will end up with negative 2 out of 3 as well. So I hope that this short sharing of how to find the gradient of a straight line will be something that is useful to you. Pick your method that you find most easy to apply so that it would cut down on careless mistakes. It will also give you confidence each time you find the gradient of a straight line. And last but not least, all the best for your weighted assessment. I'll see you again. Bye.